section 7.7 is exponential and power models. A couple things you should probably know is the exponential and power models you won't have to have memorized. So the exponential model you should be very familiar with because we've been covering that in all of chapter 7, and that's y equals a times b to the x. Power model looks very similar to an exponential model, but it's y equals a times x to the b. So note that the b to the x and x to the b are just flip-flopped, but obviously make a very large difference. Here you're taking some number and raising it to a power, so it's going to grow or decay very quickly. Here your x is fixed, but you're raising it to some power. So if b was 2, you'd have a nice quadratic function. If b was 3, you'd have a nice cubic function. But of course, b doesn't have to be a whole number. So it might be, x to the 1.792, or it can be anything. So we're going to start with an exponential model, and you're asked here to write an exponential function, and note that we will give you the equation also on the test, whose graph passes through the point 110 and 480. So you know that this equation has to go through both of these points. So I know an x and a y, and I know another x and a y. So I would just start with direct substitution. So using point 1, y is 10, I'm going to substitute it into this equation. Okay, so y equals a times b to the x. Well, y is 10, and x is 1. So that's my first equation. My second equation, y is 80, and x is 4. So basically I have a system of equations here. I have two equations with two unknowns, a and b, and it's the product of a and b, so I'm forced to do substitution. I could solve this one for a by just dividing the b over. I could solve this one for a by dividing the b over. I could also solve both of them for b. But note, depending on what x is, that's probably going to be a power other than 1. In this case, it happened to be 1. So to solve for b, you're going to end up fourth rooting things, and that's just not an ideal situation. So I would recommend solving one of these for the a variable. And it doesn't necessarily matter which one. Again, my recommendation would be to solve for the a of the that has the smaller power of b. So solve for a on the equation that has the smaller power, or exponent, I guess, for b. So in that case, it would be this equation, because b is to the first and here is to the fourth. So if I solve that equation for a, I'm going to divide by b, so that's easy. And then I can substitute that into the other equation. So I'm going to have 80 equals, I'm going to substitute 10 divided by b in for the a, and that's times b to the fourth. I'm going to stick that b to the fourth over 1. Again, an unnecessary step, but it might be helpful to see that what you're multiplying. So again, I substituted 10 over b, since it equals a, in for this a, is what I did there. And then, of course, it's just a matter of simplifying. So 80 equals 10 times b cubed, because b to the fourth divided by b is b cubed. And scooch this up. And then, of course, we can divide by 10 and get 8 equals b cubed, and then take the cube root of both sides. And that means b equals 2, not plus or minus. Cube root of 8 is just 2. And then to find a, I can go back over here, 10 divided by b, but we know b is 2, so a is going to be 5. And then last but not least, write your exponential equation. So again, here's your exponential equation right here. So I'm just going to plug in a, which we found to be 5, times b, which we found to be 2 to the x, and there is your exponential model. And if you're unsure, go back up, take those 2 points, 110 and 480, plug it into this final answer and make sure that they both work, and they will. And that's how you write an exponential model. So again, it's really just a substitution game. Then we'll look at an example of a power function. So again, a power function is y equals a times x to the b, and we want your power function to pass through the points 2, 4, and 6, 10. And it's the exact same first step. Of course, you just want to substitute those points in there. So if I have a times x to the b, my first point is 2 and 4, so I know 4 is y, and x is 2. And the second point, I know y is 10, and I know x is 6. And then again, it's a substitution game. So I could solve either of these equations. I could solve for a easily by just dividing that over. Divide this one over and solve for a. To solve for b, would be obviously much more difficult because you'd have to log things. So may as well solve for a. And just like with the exponential model, I would recommend solving the equation for a that has the base of the smaller value. So just a rule of thumb. It really doesn't matter, quite honestly, but it's just going to be the easiest route for you to take. So if I solve this one for a, I'm going to divide 2 to the b over to the other side, and then I'm going to substitute that into this equation's a. So 10 equals, I'm going to replace that a with 4 divided by 2 to the b, and that's times 6 to the b, and again I'm going to put that over 1. Be careful with your b's and your 6's, they kind of all look the same, so as I look at that it's kind of confusing, so just be careful. Now, you don't have to stick this over 1, but because I did, I can see I have 6 to the b divided by 2 to the b. Okay, so I'm going to rewrite that actually, I don't know if this will look any better, as 6 over 2 to the b. And let me make sure that that makes sense to you. So if I have 6 to the b divided by 2 to the b, since they're both being raised to the same exponent, I can just divide out their bases. 6 divided by 2, which is still raised to the b. If I distribute that through, I still have 6 to the b and 2 to the b. So I just have not changed it. It just might be easier for you to see now that 6 divided by 2, of course, is 3. So I have 4 times 3 to the b. And then I can divide both sides by 4. Please understand you cannot divide by 3 because it's being raised to a power of b. And 10/4 reduces to 5/2. And that equals 3 to the b. And now comes the tricky part. 3 to the what? 3 to the what equals 5/2. And obviously I don't know off the top of my head what that is. And because it's a power, an unknown power, I have to log both sides, because that's the only way we can solve this. So I'm going to log both sides, and what base would be good? Log of what base? Well, of course, if the base of my exponent is 3, I want to make the base of my log also 3, and see if you can remind yourself why we want to do that. So if the base of my exponent is 3 and the base of my log is 3, what happens? Well, those cancel out, and I just have b. So I have to log base 3 both sides. And then that's just going to cancel out to b. And I'm going to do the change of base over here. So I'm going to do log of 5/2 divided by log of 3. And when you dump that on your calculator, you get b equals, let's see, what did I get? b equals 0.834. And then you can go up here. Now that I know b, I can substitute. I'm going to rewrite that 0.834 is b. So I can figure out a by plugging it into this formula. So 4 divided by 2 to the b, but I know b is 0.834 equals a. And when you dump that in your calculator, A ends up being about 2.24. And so my final equation is a power model, so I want to write y equals A, which is 2.24, times x raised to the b, which is 0.834. And there is my power model.